Hi everyone, welcome back to another video. In today's lesson, we'll be going through 3 questions from the 2024 Primary 6 Prelim paper from ACS Junior. If you are interested in trying out the paper itself, it's actually linked down in the description below. Keep in mind, I do not own these worksheets. These are readily available on the internet itself. Let's start off with a relatively simple question. This one requires you to study the diagram of a toy car and then from there figure out the source of energy. Some students might make the common mistake of thinking that the source of energy is the propeller itself, thinking that if the propeller spins a lot faster and for a lot longer, the toy car would cover a longer distance. While this is not necessarily wrong, the source of energy for the toy car is actually the twisted rubber band itself. If you were to look at the diagram there and imagine there be more twists in the rubber band itself, seeing how the rubber band is actually connected to the propeller, if the rubber band is twisted a lot more, it will cause the propeller to spin a lot more and for a longer period of time. And again, using the logic we used earlier, if the propeller spins for a lot longer, the toy car would also cover a longer distance. That's why the answer for this question is number 4, which is the twisted rubber band is the source of energy. Next question requires you to take a look at a ball rolling down the slope, going from point Q, R, and S. And then from there, figure out from point R and S, what are the differences or changes to the gravitational force and the gravitational potential energy. This is a tricky question because sometimes students tend to confuse the two terms, gravitational force and gravitational potential energy. For a clearer picture, I've actually come up with a table that depicts the difference between the two. If you were to take a look at gravitational force, it is essentially mass times gravitational field strength, which is 9.8 meters per second squared, or for primary 6 students, it will just be 10 meters per second squared. Whereas if you were to take a look at the right-hand side column for gravitational potential energy, it is the mass times gravitational field strength times height. So there is an added component of height itself. One thing that can help me remember is that for gravitational force will not change so long as you stay on Earth and there is no change in mass. Whereas for gravitational potential energy, there will be a change in GPE if there is a change in height. Okay? So I've actually circled out the important part of this table for the question earlier. As you can see, GF does not depend on height, whereas GPE depends on height itself. So let's take a look at the question again. So the question is asking from point R to point S. What are the changes to GF and GPE? We talked about the formulas earlier. So gravitational force technically will not change because A, we are still on Earth. B, there is no change in mass for the ball as stated in the question. Whereas for GPE, there is a change in height from R to S. The ball goes to a slightly higher position. Therefore, your GPE should increase. Why? Because as we talked about earlier, GPE is mass times gravitational field strength times height. So there is a height there. If the height increases, your GPE increases as well. So for the answer for this question, it is actually number 3. Your GF, gravitational force stays the same when it goes from point R to S. And for the same point of R to S, your GPE actually increases because there is an increase in height. That is why the correct answer is number 3. Next, we'll move on to a short answer question, which is question number 17. Ignore the typo you see on the screen there. It states that this is question number 7. But actually, this is question number 17. So this question actually is about Sam carrying out an experiment with different length of pipes A, B, C. And then he wants to figure out if that affects the distance that the dart travels. As you can see, he has tried the experiment 3 times for each of the pipes. As a point to note, this is actually a very poorly constructed experiment, and you'll see why in the coming questions. So the first question is a simple one. It is just asking the definition of what force is. So force is actually just a push or pull that changes the speed, direction, or shape of an object. One thing that can help me remember is if you were to roll a ball of Play-Doh. If you were to put some force, whether it's a push or pull on that ball of Play-Doh, it can change direction. There will be a change in speed. And if you are forceful enough, you can actually change the shape of that ball of Play-Doh. Next, the question is asking why there is a difference for all 3 tries for pipe A. Again, this begs the question that actually this is a poorly constructed experiment. Because for every experiment, you need to remember that there has to be only one variable. In this question, the variable itself is the length of the pipe. So everything else needs to stay the same for it to be a fair test. As you can see, there are actually 2 things that Sam did not specify and did not keep constant according to the question listed. Number 1 is actually the angle of the pipe itself. The question did not state whether the angle was specified, so Sam can guess the angle for all of the attempts for all of the pipes. And that led to probably why for all 3 tries for the same pipe A, there was a huge difference between all 3 distances covered by the dart. Another possible answer for this is the amount of breath for each attempt was also not the same. Because if you were to take a look at the question, it was not specified. Therefore, Sam could have used a lot more air for the first try, and because he was tired during the 3rd try, he used lesser air. So next question is asking what is the force causing the dart to drop to the floor. This is actually a callback to what we learned in the previous question. This one is a relatively simple one. The answer is gravitational force. Again, gravitational force is mass times gravitational field strength. Essentially your weight, your mass or weight essentially times the gravitational field strength of Earth. Okay. So for the last question, it states that Sam used the same dart throughout the experiment. Give a reason why doing so helps make it a fair test. So this is what we talked about earlier, that a good and fair science test needs to only have one variable, which in this question is the length of the pipes. Everything else needs to stay the same for it to be a fair test. That is why it is a good thing that Sam used the same dart throughout the experiment. But the question is asking, why is that important to ensure it is a fair test? This is because using general knowledge, you will know that different darts can cover different distances. A lighter dart can actually travel further, whereas a heavier dart will only cover a shorter distance. Why? Because the gravitational force would actually pull the dart down a lot faster if it is heavier. That is why for Sam, he needs to use the same dart throughout. Okay, so if you were to take a look at the answer here, different darts would have affected how each dart would have traveled. Lighter darts would have traveled further, heavier darts would have traveled a shorter distance. Therefore, using the same dart throughout the experiment ensures that the only variable is the length of the pipe. Just a recap, a variable is something that we change for the experiment. So variable is, for this particular experiment, is the length of the pipe. Okay, everything else needs to stay the same. So that's it. That's everything you need to know for these 3 questions from this prelim paper. I wish you all the best for your examination, and I shall see you in the next video.